Okay, hello. We are live. Welcome to the iOS Lead Essentials podcast, the place to start your journey towards a remarkable iOS dev career. I'm Mike.
And I'm Caio.
And in every episode, we'll go deep into an essential iOS dev topic. Today, we'll talk about architecture. And we'll answer a bunch of questions we've received from our students and from the iOS community overall.
We reply to the questions with the premise that you want a remarkable iOS developer career.
Exactly. Disclaimer right there. It's not going to work for everyone, but if you want that, the next level might be good advice for you.
All right, let's go.
Let's do it.
Question number 1. What are the key elements of good architecture?
Okay, so I think what you need the architecture for is basically the future requirements. Like how can you accommodate unknown, change, which is unknown at the same time, right? Into your code base. You don't know what's going to happen, and you want your system to be flexible and do it with like the minimum cost, right? As cheaply, as fast as possible.
And reliably, right? You don't want to break features.
Exactly. You don't want to break because that's the thing. Like requirements change often, right?
Right.
Like every single day, probably. So you need something solid that it's just not going to break what you've had already there.
Actually, you can have like a robust code base that, as you say, it's solid. It doesn't break, but you can have an anti-fragile code base that gets better with time.
I think that's like good architecture. That's exactly what you just said, that with time, every decision that you make is going to make the code base better, right?
Right.
You're not going to think of it as, oh, I'm adding some craft here. I'm adding, some load that it shouldn't be there. No. Like every single decision, every single commit is going on the right direction for improvement, right? And that's it pretty much.
Okay, so trait number 1 of a good architecture is that you welcome requirement changes.
Yes.
And it gets better over time, right?
Yes.
Because if you get better over time, you're not afraid of changing it. You're not afraid of even over-engineering or making a mistake, because mistakes cost not a lot. It's easy to fix.
Exactly. That is correct.
Any other trait you can think of?
I mean, I think it's like, there are a bunch of derivatives that come through this thing, right?
Okay.
For example, what happens is you start to estimate better.
Right.
Because suddenly, you can think of you can think exactly what you need to do once you know the requirements, right? And for example, how these modules look like. If it's like a vulnerable place in your code base where no one wants to touch it, right?
Right.
No, like these things. So I think it improves estimates, and if you improve estimates, then you probably have a happier product side and a happier business side. So yeah, I think there is a correlation definitely there.
So if something is easy to change, and if it's decoupled, if a change is isolated, right, in a specific module, which means you have a good architecture, a change in one module does not break others, doesn't even impact others, it's easier to estimate, much easier to estimate. So improves
100%.
The estimation accuracy. That's a good trait. I want that.
Absolutely.
What about testing? Should the good architecture facilitate testing?
I think absolutely. I mean, I think you can't have good architecture, without being like having a testable code base, right? I don't think that's
Right.
possible in a sense where, you know, it's going to be reliable. You're going to have a reliable test suite, a very fast test suite, right? I think you need to have a good structure for your modules and the communication between them. So
if you have decoupled modules, decoupled components, you can test things in isolation, which is much faster and easier. It's hard to test when things are coupled, are messy, and there's a lot of logic going on, right?
exactly. I would say that most of the time you just can't do that, right? It's going to be so hard. If you have like state everywhere, for example, I mean, how are you going to do that? It's too costly. And it's not just costly, by the way, to do it once, right? It's like doing it repeatedly. So with every requirement, with every addition, you need to change the system. So you're going to have to go back to the test, change the production. I mean, it's just like, it's too much.
And as the project grows, it compounds, right? The complexity, the messiness.
Exactly.
It's not linear, right? The complexity doesn't grow linearly.
No, for sure not. And how many times we've seen, you know, like greenfield projects, everyone's happy the first week, the second week, you know, like things are progressing. Third week, fourth week, you know, like some dependencies come in, you know,
some changes, right? Some requirement changes come in.
Exactly. And suddenly, well, we can't do that. But what do you mean you can't do that? We just started the project. Like, yeah, I mean, this is a very common scenario. I think with good architecture and having a feedback mechanism, you know, fast, reliable, I think all these things go away. You don't have these problems.
And it's all connected, as you said, like there are side effects, positive side effects. Improving the estimation accuracy, it's a positive side effect of good architecture, testability, and etc. So what comes first, testability or good architecture?
Right.
What should we be thinking about? Should we be thinking about the architecture first or about the test first? I think one influences the other, right?
Yeah, for sure. And like if we need to, I would say both, right? But in everyday operations, like I would say start with a test.
Right.
Just always start with a test. And like the architecture is going to emerge through this process. But that's just me, you know.
Well, but that doesn't mean you shouldn't think about architecture as well and draw some diagrams first, think about some ideas.
No, of course, absolutely. Yeah.
I think especially in the beginning, the architecture kind of, if you have like some quick architectural sessions in a whiteboard, and then you start writing tests, the initial architecture is going to support the testing, right? And the testing is going to be challenging the design you created. So you're going to emerge better designs from the testing process. So in the beginning, I think the architecture will facilitate the testing, but over time, the testing will allow better designs because you're not afraid of changing it.
Yes, that makes sense for sure. Just a small comment there. I think that's like a very good practice that, again, we see a lot of people not, you know, putting it in place and having just draw a couple diagrams, just think before you start coding, right?
Yes.
I mentioned write the test first as the coding, you know, process. But before writing the test, it's a good idea to know what are you going to test, right? Like, what do you need to build? And I agree 100% that drawing some diagrams and communicating your ideas and your design decisions to others is a fantastic way of everyone being on the same page and, you know,
yes,
eliminating assumptions.
Yeah, so people say that TDD promises that you don't need big upfront design because the design will emerge. And I agree with that. But what people imply from that is that you don't need any design upfront. The idea is no big upfront design, the big expensive one.
Right.
But you can have tiny, less costly ones.
Yeah, exactly. I don't
15
think you
minutes
need.
in a whiteboard.
Yeah,
That's
and maybe
all it
that's
takes.
too much. Yeah, exactly. Definitely, you don't need, to plan every single detail
No.
and right, just agreeing on this. No, because like things change, and you need to have, you need to be adaptable. You need to be ready. So what's the saying? Always be ready, so you don't have to get ready, right?
Yes, that's it. Awesome.
Awesome.
So good architecture also allows independent development and deployment.
Yes, for sure. And independent development, for in case our audience doesn't know what that is basically working in parallel, right? So having basically a feature, and let's say this feature has a networking part and a UI part, and two developers at the same time can work independently on these things. You don't have to wait. It's not a sequential thing where
it's not a serial queue, right?
No.
Where you say, I cannot start working because I need to wait for the database, or I need to wait for the backend, or I need to wait for whatever.
Exactly. No. You can do it in parallel, and it's so much faster. It's so much cheaper for everyone, basically.
Yeah. And even if you can do things in parallel with a lousy architecture, the problem is that a lousy architecture will force you to deal with a lot of merge conflicts.
Exactly.
Right? We're going to be one small change in one part of the code affects unrelated parts. So a good architecture is not going to just allow independent development, but will allow you not to get in the way of your peers, and your peers not getting into your way.
Yes. And that's something very valuable.
Yes. What else? What about speed? Does good architecture decrease or increase speed of development?
So that's one of the big, debates that, no, like good architecture makes you work slower. I don't think so. Maybe it takes some more time to show something, but in the very, very early stages of a project. And that doesn't mean that if you don't have a good architecture and you're building something faster, you're going to show something good, or you have built your system in a right way. No, absolutely not. Right. But what happens, let's say after a couple iterations, after a couple sprints, well, I think, everyone wishes to, they wish they had something reliable and perhaps something more stable. So no, for me, I believe you can't work fast if you don't have a good architecture. And again, we're not talking about pet projects here, with a single view, show a label, a spinner or something. No, like we're talking about investment grade products that you have customers there, and they're
high
expecting
risk,
stuff.
High rewards.
Absolutely. Yes, exactly. Right.
So we're talking about a remarkable career, right? You're taking like big challenges.
Mm-hmm. Yes, exactly. So I believe you need these things.
Yeah, I like what you said in the beginning, that direction is more important than speed. And I think that's key, right? Because if you're going to the wrong direction, if you're going fast, it's even worse if you're going slow than if you're going slow.
Yeah. You need to be careful. You need to be mindful. You need to think ahead. And if you're going to think ahead, then architecture stops being just a buzzword. Is like a proactive process you do in order to facilitate what comes next, right?
Yes.
And again, you don't know what comes next. That's very important there. And it's not just, in terms of requirements, you don't know what comes next. For example, let's say perhaps it's in the same company in another department that you're called to, make something similar, right? So like have a similar set of components or something. So why make them from scratch when obviously you could have made them in such a way where it's going to be either instant to reuse, or it's
Yes.
gonna, like, the cost to make them reusable is gonna be so small, which is like basically non-existent, like in terms of the rewards that you're gonna get, right? So
reusability
these things are happening.
is part of good architecture.
Oh, 100%, 100%, right? And that's another thing. Like I see many developers confusing this thing, that they are striving to make everything reusable, and then they end up with something, let's say, suboptimal, right?
Right.
I mean, it takes time, right? You don't need to abstract too early and strive to make reusable components everywhere. No, like, if the need emerges and the time is right, then you're going to do it, right?
It should be easy to extract something reusable from your architecture. It doesn't need to be reusable from day one, but it should be easy to.
Exactly.
Which means it's also easy to replace something there. It's easy to replace a framework. It's easy to replace a service. It's easy to replace anything that is required.
Of course, that's probably one of, if not the most important principle out there, right? Like, you need this dependency inversion, where you're not depending on a specific framework, right? Rather, like, you have your system, and then you can switch frameworks. You can do whatever you want with minimal cost.
So you have options.
Yes.
Throughout the development cycle.
Yes, and you have freedom, right? That's the thing. I think, and it's such a valuable trait to have, but it's hard to make, it's hard to achieve that.
So good architecture survives the test of time.
Not just survive, it thrives over time. I think that's,
Powerful.
I think that, well, yeah, I think that's what happens there, that good architecture becomes better. And, with like more and more iterations, things should be progressing faster, and people should be happier, right? Not having nightmares about, their dependencies there.
And it's important to say that the architecture doesn't get better by itself. Good architecture is created by good teams, and good teams make things better.
Yes, of course. Everything. It's your decision. It's our decision, right? It's like we, the humans, make these kinds of decisions. So yeah, I mean, at the end of the day, it's like just decision making process for managing the risk of your product and keeping customers happy, I guess, right? So
high risk, high reward.
Yes, of course. But the other thing I want to say here is that neither the business nor the customers care about your architecture.
Nope.
Yeah, that's for you. That's for you to be proud or happy about, or sad, whatever. Yeah. Just like the business cares about, revenue, profits,
speed,
speed. Yeah, exactly. Growth. The customers care about, customer experience, being happy with your products.
All right. So next question.
Okay.
How can I learn how to create good software architecture?
Okay.
Well, practice and execution. Yeah. Well, learn, practice, execute. Infinite loop.
I don't think there's another way. Like, these things are very hard to digest. They're very hard to think by yourself. That's like the first thing we see in the junior level, where the instinct is to copy something, right? Because you see, for example, a design, you see a specific pattern, and you want to learn. You're inspired by this pattern, and that's a good thing, right? But then, you have like another requirement. You have some sort of change happening, and you just don't know how to accommodate now this change in your code base.
So a template only helps you, or a template or a pattern only helps you if you learn the foundations behind it. So you can build on top of the foundation.
Exactly. But the foundation is hard to build. That's the
how do you learn it? Books,
how do you learn it?
Courses, mentors, people more experienced than you. If you are lucky enough to have a senior developer close to you that can teach you, that is eager to pass the knowledge forward, just absorb as much you can from them. Pay them a coffee, right? Study them, like how they move, how they walk, how they breathe.
Exactly.
Learn everything you can from them.
Yep.
But not everyone has this opportunity, right? Most people are working with, I don't know, maybe alone. You know? Like they have to learn as they go.
Yeah.
Or working with people with low standards and they want to deliver something better, but they have no space, no time. So you're going to have to go out of your way and find someone online that can help you. Read books. There are a lot of good books. If you want suggestions, we can add a link in the description here with our suggestions. And courses, if you can find a good course, just go for it, you know?
Absolutely.
It's an investment. So learn.
Yeah.
Don't learn from shallow blog posts.
That's what I want to say. Exactly. Like, just choose wisely your sources, because this can like cause a severe delay in your career growth and overall abilities of writing good software.
It's probably harder to unlearn bad practices than to just learn it.
For sure.
In the first place.
For sure. Yeah.
So you need a concise path if you're learning, right? Not like random thoughts on the internet or experiments or ideas.
No.
You need a path, a concise path. Experienced people helping you, people that have done it.
Yeah. I mean, not just in like software, right? Like in anything that you can, in anything you want to do in your life, probably the best advice is like follow advice from someone that has been through what you want to do, right? It's not just, like theoretical and opinions. No, it's like you have hard facts that this person did that. They, I don't know, excelled or did fine. That's another issue, right? But they've been through this journey. So I think that's extremely important. Again, in anything that you do probably, but iOS development for sure.
All right. So learn. And then second, practice. Practice. Non-stop.
Like literally, if you don't pour like, I don't know, I don't want to say a number here and sound like, I don't know, like probably 30 to 40 hours a week just practicing these things,
Yeah. If you're serious about it.
Exactly.
If you're really serious about it.
You're gambling.
But what if I cannot practice at work? I don't know. My business value is speed. And I have to go fast. I don't have time. I don't have space. They micromanage me. They tell me what to do. They don't allow me to test. They don't allow me to think about architecture, to write diagrams. What should I do if I cannot practice at work?
I mean, again, like it depends. Like what is it? Because so if you're a junior developer and you say these things, right? Like I can't practice at work. Well, you're not supposed to practice at work. Like it's, you're not going to see these things. You're not going to find yourself one day out of the blue, able to perform well, apply good architecture principles and practices. No, I don't think that's realistic. I think like if you're in this junior,
be ideal, but as you say, not realistic.
Yes.
Right? Because for it to be ideal, you need to be in a team that has people that care about that and is going to coach you. And there are people like that. And you should look for those teams. Right? You should look for them, but they are rare.
Yeah.
And maybe you work in a place that you don't have that and it's not that easy for you to change jobs. Then you need to go out of your way. If you're serious about a remarkable career, go out of your way and learn on your own time.
Yes, exactly.
What else
and
can
again,
you do?
not even the junior levels, right? Like overall, like it doesn't matter how many years you're working, right? Like if you just don't understand some stuff, you need to find better, people that are better at this thing than you are, and like they understand these things, right? Yeah.
So not just about time, but sometimes you don't have the means to buy a course,
Mm-hmm.
right? And ideally, again, your business should pay a course for you.
Yeah.
They should train you. They should prepare you to perform in your position,
Yes.
right? But the world is not ideal. So you might have to invest from your own wallet.
Exactly. I mean,
it's an investment. It's for your future. It's going to pay off. Education pays off, especially in software.
Yes.
How much does a highly skilled developer make? It's a lot of money. A lot of money.
Yeah. Exactly. Compared to other professions as well, like that's a lot. Yeah.
Yes.
For sure.
It's a great time to be a developer.
Yes.
So learn, practice, and emphasis on this one. Execute.
Yes.
You need to execute. That's how you're going to test your ideas. No plan survives the battlefield. You learn something, you practice it, you apply it, and it fails. I thought this would make my code base easier to change. Now I have to make a change, and it's hard.
Right. Oops.
You probably misapplied it, misimplemented it. Adjust. Go back to the book, say, what did I do wrong?
Yep.
Don't give up.
That's yeah, exactly. Learn from it. What's the other saying? You can either win or learn, right? You can't lose, basically.
That's it. So execute. That's the final form of practice, right?
Yes.
It's going to face the real world. Does this work? Can I apply? Well, you can practice the bicycle, but if you have the supporting wheels all the time, right?
Or the cheetah.
Or
like, yes, no, exactly. Like, you need to
face gravity.
Yes. You need to take them off.
Execute.
And
as much as you can in every opportunity. Probably the most important thing, to execute. I know a lot of people that don't practice, but they keep executing all the time. Even if their skills are not good, they just go and try out stuff. They take risks and they learn much faster because they keep applying ideas, concepts, principles. That's how they learn.
Yeah. I think it's like, if you don't know what you're going to do, if you don't know how to do, perhaps sometimes it works like against you because it demotivates you, right? So you don't feel it, you're afraid of doing it. So however, if you are aware of this thing, aware of this dynamic, like in your brain, in your system, then maybe it's easier to override it and just say, you know what, like I'm going to do it. It doesn't matter. Like I suck at this, for example, whatever. Like it doesn't matter. I'm going to become better, So yeah.
It depends on personality. Yeah, I agree. Some personalities, they just try. They're not afraid. Some others are more cautious, but just understand your personality and find the best strategy. Maybe some people prefer to learn much more than practicing and executing. I'm just saying, if you execute more, you get more results. That's my experience.
Just persist. That's,
Next question.
Yep.
Oh, that's a good one. Speed is important where I work. I'm probably rushing a lot. So, does it take longer to create good architecture?
Okay. So I think we touched the subject briefly. No, I don't think that is true. It takes longer. I think after some time, if you have made the right decisions, I think it's going to be much faster. Well, I don't think, I know it's going to be much faster in this case.
Yes, in the long term.
Yes.
You're going to maintain a constant pace. So when you do the math, don't look at an isolate variable.
Exactly.
Like today. Was I faster today? No, look at like in 2 weeks' time.
Yes.
In 3 weeks' time. in a month's time, in 3 months' time. Because the project is not created in one day, right? It's not a sprint. It's a marathon.
Yeah. Yes.
So you don't win marathons based on your top speed.
Exactly.
Because you can run your top speed for 5 minutes and then you're tired and you don't even finish it. So
yep.
Careful with speed. Speed is important, but direction is more important. So does it take longer to create good architecture? No, it doesn't. It doesn't.
No. Yeah.
Especially in the long term. And long term doesn't mean 5 years from now. Months, 3 months, sometimes weeks.
I mean, the other thing that like I see many people just they don't think about, and this has to do with what you're saying right now, is, for example, like teams change members, right? So
all the time.
That's all the time, right? That's extremely important. Let's say you make a change that only you know for some weird reason, you know, why you made the change, so, meaning it's not visible to anyone else, like why just like a snippet of code is where it is, right? Why is it there? We don't know. And now you leave and a new member joins the team, a new developer. Well, they're going to have such a hard time, you know, understanding what's going on there. And this is going to reflect in everywhere, right? In the quality of the code base, in the estimates, in like the delivery time, in the customer experience.
Reliability.
You know? Exactly. But
and maybe you are that person. You're not a new developer. It's just you looking at your code 3 months from now. And you are confused. Why did I do that?
For sure. That's going to happen 100%, right? So that's the thing. Like with let's say if you do have good architecture, if everything is organized, and you know, like you have a low degree of coupling, and you know, frameworks live with frameworks, and you know, your business logic lives with other business logic, then it's such, you know, it's so much easier to just understand what's going on, you know, like just guess where this thing should go, right? Like whatever, where should this thing live? Yeah.
How this thing works. How is this tested?
Yeah, exactly. So again, this is about direction, right?
Yes.
Because I don't know, someone might say, I'm going to sacrifice direction. Well, they're never going to say that, but they're going to say, I want like to be faster, right? So for example, I'm going to use singletons everywhere, you know, to whatever, like locate
global mutable state. Okay.
Excuse me. Exactly. Yes. Let's say global mutable state, not just the, you know, like the bad kind of singleton. But, you know, in time, this is going to show, because, you know, the state might be everywhere, right? Like
inevitably you find very nasty bugs.
Exactly.
Or mistakes.
These bugs make zero sense, by the way. You know, like you're going to see your code and you're going to say, well, this should not be there. Yeah. Like
now mix this with threading.
Exactly.
Multi-threaded code with global mutable state. Wow. I have some bad memories of that.
Yeah. I mean, it's that's how you learn.
So it's about direction. And I mean, I like to work in projects where the direction is to deliver a good iOS app, a great experience to the customers, right? Create profitable solutions, profitable software. And if that's the direction, speed is important, but it's not the direction, right? The direction wins over the speed.
Yes.
And
exactly.
Can you even measure the speed? If you look at a single day, maybe. You probably look in a period of time.
Yeah.
It's a marathon, not a short sprint.
Yeah. Exactly.
And lousy architecture is the wrong direction, because it's not going to deliver the goals of a good application, good customer experience, profitability. I
mean, a lousy architecture is, for me, at least, it's a recipe for being sad, you know? That's it for everyone being sad.
Disaster.
Yes. Yes.
Okay, let's move on.
Okay.
Next question. Most devs I know are afraid of over-engineering. Should I fear over-engineering my architecture solution?
What is this thing? Like, what does it? I don't know what it means, over-engineering. Like, let's say, what happens if you have, let's say you have two components. One solution has two components, the other one has 5 components, right? Let's say the first solution, the 2 components, is a well-tested. It is like everything is decoupled, it's easy to change. Then yeah, I guess like if it works, yeah, I think that's fine. You don't have to.
So 2 is better than 5 if you get the benefits in both cases.
Exactly.
If you have the same benefits, go for a simpler solution, of course.
You have a bunch of asterisks there, like if, right? Like, yeah, if this thing is fully tested, it does what it's supposed to do, it's easy to change, right?
It's easy to extend.
Easy to extend, exactly.
Maintain, develop, yeah. Always look for simple solutions, but don't be afraid of breaking down stuff. So you see over-engineering as the number of components. It's like if you're breaking down too much, maybe. Is this what most people define as over-engineering? Adding too many components when one would do just fine. So if one supports what we said, all the good traits of good architecture, go with one. Simple. Always look for simple solutions. But don't be afraid of over-engineering. Because the problem is most iOS apps, most iOS code bases I've seen, they under-engineer because they're afraid of over-engineering. They under-test and they under-engineer. Yes.
That's much worse, by the way.
Yes.
And
it's more dangerous.
Yes, it is.
Don't be afraid.
I hear you. Yes, I hear what you're saying. And yeah, I mean, there are a bunch of, I don't know, like justifications for these things, like under-engineer, versus over-engineer, if these things are even a thing. But, like the problem is, I think people, like developers overall, they don't know how to do these things. They don't know like how to split concerns and, like
because it's hard, it's hard.
Open, close. Yes, exactly. Of course it is, right? Open, close systems. So again, it's easier to just stuff everything, let's say in one class, and that's it. Well, look, the UI does what it's supposed to do, right? Like 6 months down the road, you can't work on this thing anymore. You need to rewrite it, right? That's bad.
Yes. Because as you said, the customers in your company, they don't care about architecture. It's on you. So if you go there in the first weeks and you show, hey, it works. At some point it's going to stop working. And if it's a mess, and if it's a lousy architecture, it's going to be very hard to fix, to change, to keep adding features. So yeah, it's hard. It's hard to create good architecture. And that's a good thing because it's scarce. And if you build the skills, you're going to be valuable.
Yes.
Super valuable for any team.
Exactly. The other thing that I see that is happening is there is this notion that sometimes more classes means like slower system.
Right. So actual performance of running the software.
Yes, exactly. And
are you measuring it?
Well,
I know. Every level of indirection might add some performance hint in there. It might add to the overall slowness of the system. Right. But the compilers are pretty smart.
Yep.
To solve most of those cases. Sometimes you try to optimize code, and when you measure, if you actually measure it, you see that it performs lower.
Exactly. Of course.
Yeah, I don't think performance should be the first concern
No, no. And performance, like build times, for example, is just one of the indicators that you should be consulting, right? You have like another, I don't know, like dozens and dozens of other indicators that will be influenced 100%, over time based on, like, let's say, lousy architectural decisions. So if you say, no, I prefer to have faster build times than, longevity. You don't say these things, but this is what's going to happen.
But in my experience, the build times are much faster with a good architecture, especially because things are decoupled. So if I change a tiny class, I only have to recompile that tiny class.
Exactly.
But if I have a class that is globally accessible, statically accessible everywhere, if I make a tiny change there, I need to recompile all of the modules that use that.
Yes.
So sometimes you have wrong assumptions about speed, because it's hard to think about that, right? The computer is good at optimizing things. We are not that good at optimizing. So don't optimize first.
Yes.
Premature optimization. Careful.
Exactly.
Any example about lousy architecture? Any kind of component in class?
How many times we've seen, like, the user class?
Right, the singleton user.current.
Well, most of the time it's a singleton, right? It's not even a singleton. It's like, as you said, it's mutable, global state. This thing should just represent, like a single user, logged in or logged out user in the system, suddenly has like 1,500 lines of code in it, doing like everything.
Database, networking.
Persistence, everything, right? Like, yeah, I mean, that's the problem. And the premise there, is, well, actually, it's very simple. People think, oh, I'm going to use this everywhere, right? So, like, this thing it should contain a bunch of logic. It should contain a bunch of properties and a bunch of flags that I'm going to be using throughout my system, to keep state or to provide additional behavior. And that's what happened. Like, it's going to get bloated soon. Well,
it's not unreasonable, it is a reasonable solution.
It makes so much sense, right? Yes. When you hear it, it makes so much sense, but that's the problem.
And it's so convenient, and it kind of gives you an initial boost in speed,
Exactly.
But over time, inevitably, it's going to happen. It's going to become a burden.
A liability.
Yes.
For sure.
The same if you inherit from NS managed object in core data. All your models are core data models. How many craft do you bring to your domain with threading, context, whatever, managed models, all that complexity?
Yeah, that's the standard one.
Yes, and the same with Realm or any other framework.
Exactly, because what happens there is we ask teams and they tell us, no, the business says, the business has decided that we're going to use core data. We're going to use Realm, right? That's like, it's a Realm app. It's a core data app.
This is never going to change.
Well, that's crazy in my opinion. Like that's insane. And the thing, of course, is like you never know, right? But it's not just that. It's not like, let's say, whatever, like you don't change your framework. It's not just that. It's not just like your persistent stack is not going to change. Thus, you should have like managed objects and as managed object subclasses everywhere throughout your system. One thing is made for databases, right? Like for persistence. And then you have like UI stuff. You have like remote object representations that you get from like maybe there are inconsistencies there. Right. What are you going to do? Like, are you going to have like optionals everywhere? Yeah, I mean, yeah, and the answer is yes, right? You're going to have optionals everywhere.
Yeah, so it's not just about things changing, because you can make the case that, well, I've been using core data for years and I never changed it. It's about being able to test things in isolation. Right? You should be able to test your domain without having to create a database or create a managed context and load a managed model. Should be able to test things in isolation. It should be fast and reliable. Otherwise, if you mix like networking and database and everything in one model, it's going to complex things, right? They're going to be complex.
Yeah.
Very hard to develop, maintain, change, test, etc.
To say the least. Yeah. Exactly.
All right. So that's it. You should not fear over-engineering your solution. You should fear under-engineering your solution. Okay. So the next question was about core data in Realm.
Okay.
How should I architect my app with core data?
Right. Again, like this is the core data is a framework, right? Like you have your app, your system, and then you have frameworks that should live, on the outer layers of your system, right? So
they support the features, right?
Exactly.
They are not the features you're creating, unless you are a core data engineer, right?
That's right. That's right. Probably.
So that's it. Core data in Realm, they should be plugins to your application.
Yes.
Right?
Yes, for sure.
So your application should not depend on core data, Realm, or any external volatile framework. Right? The framework module, right? The core data module should depend on your application.
Yes.
That's the dependency inversion principle.
Exactly. And I believe we mentioned earlier, it's probably one of the, if not the most, I don't know. It's very important. Let's say it's very important to get architecture right, because it gives you like this abstraction there, like the separation between your business logic, let's say, or your core, and then the frameworks, the outer support.
The infrastructure, right?
The infrastructure, exactly.
They support the application, not the other way around.
Exactly.
Of course, the framework authors want you to inherit from their models, because then you cannot change it. And if you cannot change it, you need to be stuck with it. And you need to pay them, right? Even if it's a free stuff. Why would you couple yourself with that? Or if there is something better tomorrow, safer, faster, more reliable, cheaper,
Exactly. So, you need to think of these things ahead, and it's so simple, to decouple them. Like it's so simple to just say, okay, like introduce some abstractions when needed, right?
It's simple, but not easy.
For sure.
Especially, it's simple to create an abstraction. It's simple to create an interface in between your modules. But the problem is it's very easy to leak implementation details into the interface.
Yes, exactly.
So even if you have an interface, it might not be that easy to replace or test things in isolation.
For sure. It requires some,
learn, practice, execute.
Yeah. It requires time.
Next. Should I learn good software architecture as a junior developer?
Yeah, of course. But again, you need to be patient, because and set the right expectations, right? If you think, oh, okay, I'm gonna master this thing in a week,
takes years,
a month, a year.
Forget it.
No, that's not gonna happen, right? So you should set the right expectations, because otherwise you're gonna be discouraged, and you're gonna probably quit, or I don't know. So we don't want that.
Yes.
No.
So should you learn as a junior? Yes, of course. If you're serious about a remarkable career, yes.
Yeah.
The sooner you start, the better.
Yeah.
It's going to take some time. If you start 5 years from now, you're going to start from scratch. Start now. So in 5 years, you're good at it. You have a better salary, better skills, valuable skills.
Exactly.
And if you have a senior developer close to you, learn. Just learn, learn. Practice and execute.
That's it. Find good people, good mentors, If you can't work with someone, like face to face, find online, find good books, read them again and again and again.
Yes.
That's
the problem. I see a lot of developers, they ask me, which books should I read about architecture? I send them the books. They read it and say, I didn't understand anything. Read it again. Well, that's what I did in the beginning of my career. There are some books I read minimum 7 times. Minimum. Easily.
Yeah.
And maybe the first 3 times made no sense. No sense at all. Start picking up. It's like learning a new language, You try, it makes no sense. The rules make no sense. Nothing makes sense. But if you keep trying, you read it again, study, practice, execute. That's all it takes.
Yes.
You didn't understand it. Read it again. And again.
Yeah.
It will make sense.
Yeah.
You don't need to be a genius.
No, for sure not. Because I think that works against you, because good architecture is all about good processes and being disciplined rather than just being I don't know, have a high IQ or whatever.
Yeah.
It's about patience, right? And understanding of the problem, understanding of the domain and all that stuff. So it's important to, especially if you don't have someone that can guide you, right? If you step up and put some challenges, try out some challenges, right? So that's something I advise students to do. Put some constraints in your, in your practice sessions, right? So, for example, one of my favorite ones is, let's say, can you build a simple app where no class is going to instantiate another class inside it? In other words, you're going to be forced to use dependency injection everywhere. And then you're going to have just one centralized place that instantiates all your components there.
Or you can use singletons everywhere.
Right. That's out of the question. You're not allowed to use singletons.
Another constraint, no singletons.
Another constraint, exactly. Right. That's another constraint.
Yeah. You can say, can I create a simple application with 3, 4, 5 screens and only use 3 if statements?
Yes.
And it should have networking, database, and everything. Yeah. You can.
Yeah.
You're going to learn a lot by putting constraints. I like that idea.
Yeah. Give it a try. You might be surprised. It's harder than it sounds, most probably.
Yeah. By putting constraints, you're going to look for answers there you were not looking before. You're going to research things. You're going to find books about it.
Exactly.
Right? For example, if you want to learn functional programming, no mutable state anywhere. Try to create an application that doesn't mutate state. Games, web servers that would not mutate state.
Yeah. One of my favorite side effects is that, if you start putting any constraints, then you can't just copy and paste code, which is
nope.
Yeah, which is the default way of learning. And sure, if someone hasn't written any code in their life, I think that makes sense. But if you reach, a certain level and you understand somewhat UI kit, you can build an app, a simple app or whatever, then you need to move to more advanced ways of training. All right. So copying code, just to make your device show something, that's I don't think that's that beneficial in the long run for your career.
Yeah, but you should challenge yourself.
Yeah.
If you go to the gym and you can lift 10 kilos, what do? You try with 12 next time.
Yep. Exactly.
If it's easy, you go put 15, 20, 30, and that's how you grow. Keep challenging yourself. Good one. So, that's a good one. Should I care about good architecture in a small app? Simple app. Should I?
I think it's too vague. What do you think?
Yeah, because it's easy.
Exactly.
Especially if you're a junior, going back to the previous question. Yeah.
Mm-hmm. Yeah.
If you have a simple app, do the best you can. Write all the tests. Go for the best architecture you can come up with. Clean up the design. Put challenges, constraints, and go for it. That's how you learn. It's simple. Yep. Do it when it's easy.
Yes.
That's it. That's how you're going to learn. That's how you practice. And that's how you execute. You're not going to be able to lift 30 kilos if you cannot lift 10, and then 12, and then 15.
Yep. That sounds about right.
I think that's it for this one.
Okay, yeah.
Do it when it's easy. Of course. So, should I care about good architecture practices when applying for jobs?
Okay. Yeah, of course. I mean,
if you want to work with remarkable people, with remarkable teams, yeah.
Exactly. What are you going to show? Like, if you're not going to show, good architecture practices and, like your testing skills, what are you going to show?
I understand this question. They are afraid of over-engineering and being left out. Like, oh, this person over-engineers. We don't want to hire them.
Right.
But that's a filter.
Yeah.
That's a filter. And you don't want to work with them as well. Right? You don't care about the same things.
Yeah.
So probably not work with them. It's just, you're going to be unhappy. Right?
I absolutely agree. Yes. Like, for me, the best, I think one of the best, listings would say, show us a couple ways of, building this feature.
Right.
Show us 3 ways, 3 different designs, but do not change your test, just refactor. Show us that you can refactor your code, and have Git there to demonstrate your solutions.
Very advanced.
Yeah, I think that's what you should, strive for here, right?
Yeah.
Like these.
I mean, if you can do that, you're gonna get the job for sure.
Yeah.
You're gonna get a good offer.
Yeah.
Yeah. So if you agree that you're going to get a good offer, if you can deliver an amazing application with clean tests and clean solutions that you can easily refactor, why wouldn't you want to build that skill and demonstrate it to your potential team, your next team? Yeah, go for it.
Exactly. Yeah.
Should you care? Yes, you should care. If you're serious about a remarkable career, yes, you should care.
Okay.
Next. I am not a software architect.
Okay.
Should I learn how to create good software architecture? That's not my job. I'm a developer.
Right.
Well, yes, you should learn, because every code change may affect the design. So somehow we are all architects.
Do you make decisions for the project? If the answer is yes, then you're an architect. You don't have, just leave the fancy titles and all that stuff. Everyone should be aware of what they're doing, because that's the other problem. You have people, I don't know, I'm reading these things that sometimes they say, oh, an architect doesn't code, or an architect codes 10% of their time and stuff like that. And I'm like, really? I don't agree with that, to be honest.
I don't think there's any law.
Yeah, exactly.
or rule. It depends on the project. But
exactly. And that's because, first of all, it shifts the responsibility of making good decisions to someone else. The other downside I can see is that you're not incentivized ever to make good decisions, because perhaps you think, oh, I don't want to be an architect. I just want to be a senior iOS developer, whatever. Then, you're not motivated enough to make something, all these things that we've been saying so far, something good, a great structure and everything. So I find this very, very problematic, and this is a serious issue.
Yes,
in my opinion. So yeah, I mean, every decision you make, it affects the architecture.
So if you're not making good decisions, you're going to the wrong direction.
Yes, for sure. it's one of those cases that if you're not going in the right direction, you're going in the wrong direction. Like there's no, neutral zone or anything like that. It's like, no,
Because design is one of the highest values of software. We have the features that everyone knows, but what about the design?
Right.
Design is what allows you to keep adding features, changing the features, improving it.
Yes.
You want your code base to get better over time, not worse.
Right.
And that's design.
Yes.
Right. Even if your customers or your boss doesn't care about it, they do implicitly because they care about the outcomes, the goals.
Exactly.
And it's your job to make those decisions to allow those goals. That's the value you bring as a developer, right? Making decisions. If you're not making decisions, you probably don't have a position that is very valuable in the company. You're not going to have a remarkable career, right? So it's not a problem of if you should have good design or not, if you're not an architect. It's like you should build those skills so you can grow with time, increase your value, and achieve a remarkable career. A good salary, work with great people, autonomy.
Yes. Exactly. Like winning, and happiness. So winning for the business and happiness for the customers, they both come through you, right? The developer, because you are the one that builds what's going to generate the earnings through the product, right? So again, like if you're making decisions, you're affecting the architecture, you're affecting the design. And I agree with 100% with what you just said, that customers don't care about your design decisions. They don't know about design decisions, right? Like
not directly.
No, they just want to be happy, like happy customers. That's and the business as well. They just want, growth, revenues, profits, all that stuff, right? So it's imperative, in my opinion, to understand this. Otherwise, you're just writing code for what's the goal here, and just for the sake of writing code.
Yes.
Well, sure. I mean, that's a noble, thing to do in your own personal project, but other people, well, the whole livelihoods of other people are at stake here. So, be responsible. That's what we want to say here. Be responsible, and architecture will make you respond. Like if you think about architecture, that's gonna raise the level of responsibility, I believe.
Not just responsibility, but also value and the returns, the rewards you get from it. Yeah. Right? You don't want to increase just responsibility. You want to increase the rewards, the value, right? So you need to build the trust, build those skills, go there and get bigger challenges, higher positions. Always aim for more.
Let's reverse the question for a second and say, why wouldn't you want to be an architect? Not on your role, right? But as a skill, when this is like a timeless skill to develop.
Right.
I mean, it's applicable everywhere. So if you want to write software, like literally it's applicable everywhere. It's not like just a framework or a programming language that just emerges, like let's say the last 3 years, this thing skyrockets in demand and popularity, and the next 3 years is just going to plunge. No, like if you're making something, you're going to have to make good structural decisions. So I think that's a fantastic opportunity, as you said, to increase your value as a professional.
Yes. And we get a lot of emails from developers saying, well, I have 10 years experience with PHP or JavaScript or Ruby, and I'm planning to transition to iOS because I can get better salaries. I see there is a lot of demand where I live, but I have to start from scratch.
Yeah.
Get a junior position and start from scratch. Why? You have 10 years experience. Just transfer that. You just need to learn the syntax.
Yeah.
But you can only do that if you build the valuable skills that are timeless, right? That work in any software project.
Exactly.
If you are a framework developer, like I can write any app if I'm using Alamo Fire and some other frameworks, then you cannot transfer that to other platforms.
Yes.
other opportunities that may show up to you. You should be ready. So you don't need to get ready.
Yes. Yes, exactly.
Next question. What is the best software architecture? The best one.
Okay.
Which one should I learn? So I don't need to learn the other ones. Just the best.
Yeah. Okay. Clearly, yeah. I mean, I don't think there is a best. I think you should learn everything. You should learn, there are no silver bullets, basically. If you're looking for silver bullets, then I don't think you're going to find them.
So I think they're asking what is the best pattern, right? But the idea is sure, learn the patterns, learn the foundations behind the patterns, right? Learn the principles, and then you can apply any pattern, right? You can learn and build on top of the foundation. If you just learn the pattern, you might not be able to translate it to other challenges.
Yes. And again, this is like the architecture on the pattern, because people are looking for a simple solution that is going to solve all their problems. Excuse me. Architecture is about discipline. It's about patience, right? No, there is no one. Depending on your scenario, depending on your situation, you're going to have to navigate differently.
There are so many variables: budget, staff, skills.
Exactly. Yeah.
You cannot just say, well, this is the best one. Well, in which scenario is this the best one? Because there are good patterns and you should learn them. For example, if you're working in a financial app, there are good patterns for representing money with currencies and representing taxes. This problem has been solved many times in different contexts, in different countries, in different taxation systems. So yes, when you're dealing with a mature problem, there are patterns. They've been used and they are proven to work. And if they don't perfectly fit your domain, if you know the foundation, you can build on top of it and you can adapt to solve your problem depending on the variables you have, the budget, the team, the skills. So you need to learn the foundations. There is no best architecture. There is no silver bullet.
I'm going to make a statement here. And of course we can't, I don't think we can ever be able to verify that. But I think that if architectures or, architectural design patterns didn't have a name, let's say MVC, Viper, whatever, MVVM, right? I don't think we would have so many, people thinking, which one is the best. I think the names, their influence.
It's marketing.
It's marketing, exactly. Exactly. It is marketing.
They're cool names. Come on.
They are. Yeah. Yeah, but that's the thing. For many years, the average iOS job listing would say we need an MVVM iOS developer, basically. They would say the number one thing, MVVM, right? What? And then, yeah, because that's what was trending at the time, right? And of course, many of these code bases would not reflect the MVVM pattern.
No.
That's the other thing, right? Yeah.
So it creates a lot of incentives, right? This job posting, because if you want to get a job and every job posting asks for MVVM, instinctively, you're going to say, well, MVVM must be the best one.
Exactly.
Thus, I'm going to learn MVVM, only MVVM, and that's it.
Yes.
I have infinite jobs until the next fad comes in, and now it's MVP.
Yes.
And then you need to learn MVP. And so the market is incentivizing the developers to learn certain skills and not others. So it might be an incentive for you to get a job, but in the long term, you don't need to look just at what the market is saying, but look at successful people. What are they doing?
Yeah.
Right? People that go against that common knowledge, the average.
Exactly. Open old books. The boring stuff, learn the boring stuff, which, of course, I'm only saying boring here because most of them, they don't have a name, there's no cool acronym here for identifying them for marketing purposes, as you said. I mean, I think there's so much confusion when you say as well best architecture, and most people, again, that's my opinion, I think they're gonna put like a UI design pattern,
right,
as the architecture of the whole system, and they're gonna define, like the system's architecture with, let's say, MVC, where clearly you have a V there. V is a view, and they're not even thinking abstractly about the view. It's just like UI, right? Like in our case with iOS, UI view controller, a UI view, a UI button, whatever, right?
Because how many variations of MVC there are?
Exactly.
How many variations of MVVM and MVP? Yes. Depending on platform, depending on framework, depending on knowledge, depending on skills, depending on team, depending on problems, right? It's not a very fixed thing. They are guidelines.
Yes.
For defining your user interface components. And all of them work pretty well, which is the next question here.
Okay.
So, yeah, there are no best architecture. But as you said, there are patterns. Which one is the best pattern? MVC, MVVM, MVP, or Viper?
Right.
I like this question because it's true, as you said, it's a pattern. It's not an architecture. And more specifically, a UI pattern.
Yes.
So which one is best? Depends. The one that solves the problem at hand.
I mean, exactly. And the problem at hand, is going to have networking, is going to have databases, is going to have location managers, whatever. Like, it's going to have a bunch of things that are not included in the acronym, or rather in the letters of the acronym, right? So what you're going to say, I'm using MVC, database, D, and N, like for the
MVCDN, the new
MVCDN, right? Like, I don't know. It doesn't make sense, for me. As a UI thing, yeah, I think it's, all these ways are fantastic to structure your project. You structure your applications, per screen or per UI element. These are fine ways to do it. But overall, I think you just need to separate components and organize them in, like a completely different manner. Take Viper, for example. Again, it's supposed to be a template solution, right? But then you don't have these things. But somehow, especially like inexperienced developers, they're going to think like everything should be something of one of the letters of the acronym, right? So you're going to have like an interactor, for example, doing XYZ, right? And there's going to be just one interactor. Like, how many times we see that? Well, yeah that's going to be problematic. I don't know.
Yeah, the acronym doesn't help you implement it.
Yes.
And if you're structuring your user interface, as you said, any of those patterns will do just fine. In the hands of an experienced team, any of those patterns will do just fine for the user interface. MVC, MVVM, MVP. Yeah.
Yes.
Just choose one. It's mostly personal preference because they are all testable and flexible. And it's easy to refactor from one to the other as well because they're so similar.
Exactly.
They're so similar, right? If someone cannot deliver a good MVC solution, I don't think it's a pattern problem. It's like it's unlikely they will deliver a good MVVM or MVP solution.
Exactly.
Because those patterns are so similar and they are so flexible and testable.
Yeah.
There are no reasons why something will be terrible because of MVC. That's just unrealistic. They are all fine. Just pick and choose. If you cannot choose, maybe you're working in a team that prefers MVVM. Deliver the best you can with MVVM. They're not that different. When you learn the foundation, they all come from MVC.
Yep.
Right? When you learn the foundation, the principles behind it, you can solve the problems in the user interface with any of them.
Yeah, agreed. Exactly.
All right. Next, I just joined a new team with a terrible legacy code base. The architecture is a mess. Is there anything I can do to improve it? Where should I start?
Okay. Yes.
Well, first of all, don't try to rewrite it. Okay.
Exactly. Yes. And there's like, yeah. So usually we hear the word refactor with the word legacy.
Right. Meaning a rewrite rather than
meaning a rewrite.
Tiny refactoring is to improve it.
Yes. And of course, the reason there is that you just, like, if you're going to change something, how do you know you didn't break anything else? You know, like, you can't know that because you don't have any tests backing you up.
Well, yeah. So you're saying that a legacy code base does not have tests. That's the definition.
Yeah, I like this definition. You know, otherwise, you know what's going on. You get feedback when things are right and when things are wrong. Right.
Fast feedback and reliable. Yes.
Exactly. So that's my opinion there. I agree 100% with what you're saying, because it's so tempting. Let's say you're starting to understand, you know, like good principles and everything, and then you see a code base like, you know, like a legacy code base with, let's say, there's no separation of concerns going on, there's tight coupling, singletons, and all that stuff, or rather mutable global state.
Not just see it, but you inherit this code base, and it's
exactly.
your problem now.
Yes. And all you want to do is go there and fix everything. But
yeah, you want to execute, right? You learned, you practice, and you have the chance to execute now. And you have this mess in your hands.
Yes.
And you just want to go there and rewrite the whole thing in one go.
I mean, don't do it. If it works, just leave it there.
And if it doesn't work and you have something to fix, you refactor that part you want to fix, right? Refactor just that part, improve it, add some tests there, and slowly, every time you change it, the places you change, the places you touch, you add more tests, you clean it up. And over time, if you keep maintaining it this way, at some point you're going to have cleaned everything.
Yes.
Or some places you're not going to clean because you don't need any change. It's very stable. It works.
Exactly.
Even if it doesn't have tests, doesn't have the best architecture in there, the best design, it's stable. Don't change things that are working. Only the things that are not working.
Yes.
I think that's a safe bet.
Yeah. I think that's sound advice. And again, patience. Like, don't go after a mess just because you can identify the mess. If it works, it works, you know?
Yes.
Don't break it.
All right. Next one. The rest of my team doesn't care about good architecture and good practices. What should I do?
Find another job, probably. I don't know.
Well, yeah, you can't win against the majority, right? So the collective is going to win.
Yeah.
So if you care about it, right? If you're not in a leadership position, if you cannot influence change, and you care about your future and you care about, I don't know, good practices, maybe you should move because you're not going to be happy there, right? Every change you make, someone's going to come and break it and make a mess on top of it.
Exactly.
So I think it's more a matter of happiness and future growth.
Yes.
Right? It doesn't mean that this team that doesn't care about good architecture is not going to have a profitable career. Maybe they will. But are you going to risk your likelihood of achieving a profitable and happy career?
Yes.
Because if you care about it, it's very hard to be around people that don't care.
Exactly. If you care and other people don't care in the team, that's going to be a nightmare. You're going to have like conflict all the time. And
yeah. And sometimes you're going to be reviewing some code. And you know that even if you send a message and you ask them, like, even if you want to request some changes to improve it, you know it's going to be in vain. So you stop trying at some point.
Yes.
You know, it's just like, it's not good.
No. But I mean, if you're in this journey of growth, this is like a milestone. If you reach a level where, you know, you started, let's say all developers in the team started at the same level, and now you're seeing these things and you have conflict because of, let's say, quality assurance issues in PR, in pull requests, and like features, I think that works. That works great for you because it validates that like you have leveled up and you have a choice. Like can go somewhere else, try to find something better.
Yeah.
Or
if you care, you need to find people that care as well.
Yeah. Or make them.
Them. Good one.
Yeah, that's hard. I don't recommend that to everyone.
Right.
But,
what is the saying? If you are the smartest person in the room, you are in the wrong room.
Yeah.
Find another room.
Yep, for sure.
Okay, next. My manager wants me to sacrifice good architecture and good practices for faster delivery times. What should I do? Okay, it's speed again.
Yeah. Okay.
Yeah, speed is important. But is this a momentary thing? Is he asking you to say, hey, we need to go fast because we have a marketing date that we need to meet, man. Come on, like, there's nothing you can do about it. Or is it a constant thing? It's just like recklessness.
Yeah.
Because depending on the case, like, maybe your boss knows something that you don't.
Yeah.
Right? And you should work with him, not like, it's not a you against them.
Yeah. Again, you have this conflict, and then you need to assess, is this conflict continuous?
Yes.
If it is, then it's going to be a nightmare, like to work like this. And these things happen all the time because of, like a very hot market, right? Both for the business side and the developer side, the demand and the supply in the job market. So these things are common. Be prepared for to see them.
It's a fierce competition out there. The businesses just want to go faster than the competition. But to go fast, you need to go well. That's where the discipline comes in. That's why you need discipline. Because if you have discipline, in the long term, you're going to win the race.
Yeah.
It's a marathon. So sometimes you have a deadline that you cannot change. And maybe you need to work a little bit harder. Maybe don't sacrifice the design, but maybe sacrifice time, get some extra time, make some extra bucks, can help you invest in something, buy a course, invest in skills that are going to make you faster as well, deliver better solutions with tasks. By eliminating the risk, with good architecture and tasks, you can go faster because you're not afraid.
Yeah.
So understand, is this a constant thing? Is your boss asking you to do this all the time? You just don't care about quality at all? Again, if you care about quality, you need to find people that care about the things you care as well. Otherwise, it's going to be very hard.
Yeah, exactly.
But if it's a one-time thing, maybe go out of your way, deliver a good result, help your boss look good to their bosses. And that's how you grow in a company,
Yeah.
Go the extra mile. Do your best.
Exactly.
If you build trust with your boss, he will leave you alone, right? And he's not going to micromanage you. If they're micromanaging you and telling you, go faster, don't test, do this, it's just that you're not making the decisions. If you're not making the decisions, it's very hard to grow in that company, right? Because you're not taking risks. You're not taking responsibility. Exactly.
I believe the term is skin in the game, right? So if you don't have skin in the game, then you won't grow together.
Yes.
Like everyone has their own incentives, and most of the time are not aligned, and that can be problematic. You can't expect the same things while, if you did have this fantastic relationship and going the extra mile and over delivering and all that stuff. For sure.
Yeah. If you're serious about a remarkable career, right? Working with remarkable people, not being micromanaged, you need to go the extra mile.
I mean,
it's that easy. Well, it's that simple. But it's that not simple.
Easy. Yeah. It's going to take some time, but that's it. Yeah.
Okay. I think that's it for this podcast.
Okay. That was awesome.
That was great. Yes. Love it.
Yeah, it was, I feel lighter after sharing all these things.
So let us know what you think. If you have any questions, leave them in the comment section.
Exactly. And we'll see you again next time. Bye, y'all.
See ya.